eu queria chamar o Gareth, que é presidente da Fundação Microbit, que deu ideia e iniciou um movimento que chama Robótica de Terceira Geração. Queria pedir palmas, então, para que a gente recebesse nosso showman de hoje. Logo depois vocês vão ver o David.
Thank you, Art. That's a very big picture of me. Thank you so much for having me here at the Let's Go Crazy Festival, as Alvaro has just renamed it. I'm really excited to be here, and thank you to Positivo for inviting me. As you can see from the big screen, I'm Gareth Stockdale. I'm the CEO of the Microbit Educational Foundation, and I've been asked here today to talk about how to build a nation of inventors. And when I was asked to do that, my first question was, I have no idea. What is an inventor? So the first thing you do when you're starting to do some research, I went to Wikipedia. And Wikipedia told me that an inventor is a person who creates or discovers new methods or device or other useful means that becomes known as an invention. So in essence, an inventor is somebody who invents stuff. Not very helpful. So I dug deeper. Going back to the Latin is always a good start. So the Latin, invere, means to find. So in essence, we're saying if we want to build a nation of inventors, we're asking people to be able to find solutions to help solve problems that we're facing today. And I think we can all agree that our digital future is already here. There are a few less robots than I was expecting, and a lot more issues around data privacy. But I think we are safe to say that technology is beginning and is shaping all aspects of our life. So how do we prepare our children for that future which is already upon us? There's an interesting stat that Forbes magazine came up with, which was that 65% of children who are entering school today will do jobs that don't exist yet. So if those jobs do not exist, how can we make sure that our children are prepared for that future? I'm not sure where they got that 65%. I've never been able to find that out. But I think it's a really sort of interesting way to look at what our future holds. So the Microbit started out in the UK. I was the co-project lead in the BBC. And our project was a direct response to the digital skills gap that we saw in the UK. If we all agree that our digital future is already here, and that technology is impacting on all aspects of our life, and that we all agree that we want to empower children to create innovative solutions to those issues that we face, then we looked at what the situation was in the UK. Everybody agreed, the stat at the top, 60% of the public thought that coding was an essential skill. There was going to be 1 million unfilled jobs by 2020. So that's all great. But on the other side of the coin, only 10% of adults knew how to code. And shockingly, 83% of girls were leaving school with no knowledge of coding. That's not being a coder, that's not taking an exam in coding, that is having absolutely no knowledge of coding, never experienced coding at all. So that is where the Microbit came from. That challenge to try and bridge that digital skills gap in the UK. And then I thought, what does an inventor look like? So I went to Google and I did a search, put in what does an inventor look like, and this is what came up. And as you can see, it's generally white, male, and old. So I thought maybe we can change that up a bit. This is what you put in when you look for a cartoon of an inventor. Again, generally men in white coats, lack of hair, maybe glasses. A cat. I don't know why a cat, but again, our thought in the BBC was that in order to get people creating those solutions that we want for the world, we need to broaden participation. We need to get more girls, we need to get more underrepresented groups taking their first steps with technology. So how do we ensure that no child is left behind? That we are ensuring that we are able to reach those underrepresented groups, those people from lower income backgrounds? And how do we ensure that all aspects of society are involved in shaping those solutions so that we have solutions that represent all of our interests? So at the foundation, we believe that we shouldn't leave any child behind. And our vision is to inspire every child to create their best digital future. And I just wanted to spend a moment just deconstructing that statement. So the first statement, inspire. We don't want to teach children, we want to inspire them. We want them to be enthusiastic about what technology can do to shape the world in which they live in. We want it to be every child. Every child, we think, should have access to these skills. They are foundation skills for the 21st century. If all children haven't got those accesses, then they are going to lag behind. Create. This is about digital creativity. It's not about learning to code. It's about using code as a method to explore your creativity, your innovation, and to invent for the future. And as I said, we think that these skills are foundational for the 21st century, and only by equipping all of our children with those skills can we ensure that we have an equal society in the future and that the solutions that are created represent all of us. We want to move from this image of an inventor to something more vibrant, more colorful, more representative of all of our people. These are just some of the creations that have happened with microbit over the last couple of years. So what is a microbit? I don't know how many of you have know a microbit. Here's one in my hand. So it's a pocket-sized computer that can fit in your pocket. But it was designed by the BBC and 29 partners. And the beauty of the microbit was that it had education at its heart right from the start. We wanted to build something that was suitable for 8 to 14-year-olds taking their first step into coding. And many of the conversations we had with the designers and the technologists as we were creating the microbit was, what does this mean to the child? It's great, yes, we can do it, but what does it do to help their learning? We brought together that 29 partners, so people like Microsoft, Samsung, ARM, NXP, all sorts of great companies, and we all combined our efforts to create the microbit, and we gave away 1 million microbits for free to every 11 and 12-year-old in the UK. So I'll give you a quick walkthrough what the microbit is and what it does. So the first thing it has is a 5x5 LED matrix. When we started the project, we love things like the Arduino and the Raspberry Pi, and we think they're a brilliant, brilliant solution for people to make and create. But what we wanted was to allow children to take their first steps in a way that was unthreatening and easy. With the 5x5 LED matrix, you can pick up a microbit and you can code within 3 to 5 minutes, put your name, put an animation, take something from the physical, from the digital to the physical, and have that microbit moment. We felt that too many children were failing in their first step with technology, And we really wanted to ensure that we had that low floor to allow all children to have a positive first experience with technology. It has push buttons, so it's very tactile. You can input with the push buttons. It's got, on the bottom here, as you can see, it's got an edge connector. It's got a place for crocodile clips, for banana plugs, so you can build on it, connect sensors and motors and really extend. So you've got that low floor, but you're also able to build and have that high ceiling. We ensured that all of the electronics and all of the chips were exposed. We felt that the generation at the moment were the most digitally enabled generation we've ever had, but everything was so nicely packaged behind plastic that children just thought that magic was happening, and we wanted to demystify technology. So a deliberate design choice to have everything exposed at the back and everything labeled so you could see what was what. We've got the micro USB at the top there, so it's easy. It acts as a pen drive, so you connect it to your computer, you program it, you download the file. It's got a battery connector, and that's really important. So you can take it away from your computer and create real-world solutions. You're not tied to your computer. It's not just about being on the screen. It's about being in the real world. It's got Bluetooth and radio. So you can program it from your phone, from your iPad, but you can also do radio to radio. So you can do one microbit controlling another microbit. There was a group on the Inventura stand yesterday, a group of children explaining to me that they'd done a project where they'd looked at the fitness of children in Brazil and decided they need to do something to get more children running around. So they created a treasure hunt using the microbit with one microbit as the treasure and sending out a radio signal to the other microbits. And then they ran around for 30 minutes to try and find that one microbit. And I think that's a really good example of the physical and the digital working together to create a real-world solution. And we've also got a magnetometer and accelerometer, so the microbit knows where it is in the world and where it's pointing. So again, you can add extra inputs and do extra things with it. It also senses temperature and senses light. So as you can see, we designed something that had a really low floor. Children could take their first steps really easily, but a really, really high ceiling. And with the simulator on the MakeCode code editor, it means you don't even need a microbit to get started. You can go online, you can start programming, you can use the simulator to see what it would look like. But we do feel that the combination of physical and digital, that ability to take it off the screen and get kids working in the real world is really, really important. We found that marrying of physical and digital, when they take that first moment and take it off the screen, we call it the microbit moment, and you see the children's eyes light up as they think, oh, I've created that. And that's what we want children to see and feel. You can program it via a browser-based code editor. So this is created in conjunction with Microsoft. It's a simple block-based programming editor, but it has JavaScript, so you can flip between the two. As you see, you can really easily create something in your area there and then download it. We've also got a Python editor. A microbit also works with Scratch. So you can see that you can take those first steps to Scratch and build your creativity, then move on to a block-based coding editor, and then on to Python. So to recap on what the microbit is. It's easy. We wanted it to be easy. We want to go from code to download in minutes. It's affordable. We're a not-for-profit, so we want to keep the price of the microbit as low as possible. We've got loads of free resources online. All of the software editors are free. And we continue to develop and create more free resources and more editors. Alongside those 3 main editors, we've got lots of other community editors. So the beauty of the microbit is you can find your own way in. And it embeds education in a meaningful context. And it's also supported by hundreds of accessories. So we've got over 200 accessories. And as I said, those free software and editors and learning resources. And what we think is really important with the microbit is the ability to build real-world applications. As you said, to look at problems that you're facing as a child and create solutions to those problems, or to follow your passions. If you're interested in sport, if you're interested in music, if you're interested in fashion, let's harness that. Let's get the kids creating on things that they are passionate about. Coding should be a way to follow those passions. We're teaching them to do that using technology rather than teaching them to code. And just as a very simple example of what you can do, so this is a Fitbit. I think we all know what a Fitbit is, but you can create your own Fitbit using microbits. So if you've got children in your class who are interested in sport, let's get them coding and using technology to make their own Fitbit. We've had a wheelchair basketball team in America who used the microbit to measure their training, to show how they were increasing their acceleration as they trained harder. So again, harness that passion, harness that creativity to create real-world solutions and use technology in a positive way. And who are the foundation? So the foundation were spun out of that original BBC project. We're a not-for-profit, and the microbit is now available in over 60 countries worldwide. And we have over 30 national projects happening right now in the world. There are over 4 million, around 4.5 million now microbits out there in the world, and we think we've already impacted around 18 million children. Our aim is by 2025 to impact 100 million children around the world, and we need your help to do that because there's only 30 of us. So there's a lot to do. And we work in partnership. We've got 140 delivery partners around the world, ranging from people like Microsoft to small not-for-profits and charities. And what have we learned? So with these 30 projects, with these 4.5 million microbits out there in the world, with our reach, we see as the foundation our role to bring together best practice on using physical computing to enhance learning. And we're spending a lot of time trying to build frameworks and research to show success and to make our practice better. And what we love is that physical computing creates excitement. When children are in the classroom using the microbit, and we met a bunch of teachers who are using microbit in Brazil yesterday, who were saying that their children were disappointed when their lessons end using microbit, which I think is really rare, because when I was a child, when I was having my lessons, I was always happy that they ended. And microbit's really good at making those abstract concepts tangible. It's really good at that sort of design process. If we're trying to get a nation of inventors, if we're trying to get people to create solutions using technology, we want them to be designing, building, prototyping, iterating. We want them to make mistakes and to learn from those mistakes. Microbit and physical computing is also brilliant at building collaboration, teamwork, communication, and problem solving. And we found that really, really interesting. And just a little bit more on that, it allows deeper engagement with learning, the physical computing, knowledge and skills built together. And also increasing confidence in your use of technology and confidence in the way that you interact with your peers and your classmates. And then some of the things that we've done and some of the results from around the world. So these are stats from the initial UK project, where we did some independent research with an organization called Discovery Research. It was a really positive student response, because when we started this project, we thought we had a really good idea. But again, until you put it into the hands of children, you never know. So 90% of children said that the microbit showed them that anyone can code. 88%, which was really important for us, made children think that coding wasn't as difficult as they first thought. It was about breaking down barriers and getting more children involved in coding. Also had a positive effect on attitudes to taking coding for future options. There was a 70% increase in girls saying that they would take coding as an option in future. And that was really, really encouraging. And we found that that ability to provide context to learning and create those real-world solutions seemed to really cut through for girls. We also found that it increased the confidence of the teachers that were using microbit. We feel that building teacher capacity is a huge goal that we need to work on. And again, speaking to some of the teachers yesterday who are using microbit in Brazil, when they first started using it, they're not technologists, they're geography teachers, they're maths teachers, and they were scared. They didn't want to use microbit, they felt scared. But after taking those first steps and learning with their children, they felt more confident and it improved their practice. And that we were surprised that the results were so strong on that. And then just an update of where we are in the UK now. I think the other thing to say of what we've learned is there are no quick fixes. To change the way that coding and creativity and digital creativity are taught in schools is not an overnight project. It needs application and effort over a long term. But with the latest GCSE results this year, it shows that the numbers taking computing as a subject has gone up by 7.6%. The number of girls taking it as a subject has gone up by 14%. So we are making progress. But it's a long process, and you need to be in it for the long term. And then just to go through some case studies of countries that are using microbit at the moment and what they've done. So Plan Cibal are one of our great partners in Uruguay. And they've been working with microbit since 2018. Their program has got 3 aspects to it. One is computational thinking courses, then class workshops with remote teachers, and then they also offer for keen students who haven't got access to teachers, online tutorials. It's been really successful. They had initially 10,000 microbits, which they offered out to teachers and pupils, and those were gone within 3 days. They're really happy with that, and we're continuing to increase our work with them. Singapore was another country that was really early in their microbit program. They started in 2017. They built a program, with computing not in the curriculum, and they wanted to encourage using technology across all curriculum areas. They created something called the Digital Maker program, and they invited 5 teachers from each school in Singapore to come along and be trained. And as a result of that training, all of those teachers then created learning materials which were shared with the rest of their cohort, and it grew from there. They also encouraged intergenerational learning. So they invited in parents and grandparents, and whole families learnt digital skills together, which was really, really important in Singapore. That has now led to computing being a compulsory subject in Singapore, and they do 2 hours a week, and microbit is at the heart of that. So it's affected curriculum change, which is great. I've just had a big 5-minute sign come up on here, so I'll have to hurry through the rest of this. Lithuania is another one, and I love this picture because there's always lots of buggies happening and lots of things happening with buggies. But this is what happens with microbit. There's a real creativity to the way that the buggies are produced, and you can see the flowers and the people, and it's amazing. But they're a not-for-profit. They started in 2017, and again, they've affected change in the Ministry of Education. All schools have been involved. Western Balkans, again, another project that started this year. They're reaching 1 million students, training 19,000 teachers. And again, you can see the positive elements of teachers taking their first steps and building and going past their fear. Denmark, this was created by the national broadcaster DR, and I wanted to highlight this one because it's not only getting microbits into the hands of pupils, it's not only training teachers, but it's also about attitude change. We need to ensure that parents, grandparents, and the wider public are aware of the importance of these skills in building future prosperity for countries. And then Canada, another 100,000 microbits distributed across Canada. I just wanted to highlight one project which was done in conjunction with the Canadian Space Agency. So all schools in Canada got a microbit with a CO2 sensor, which they then did CO2 readings, relative humidity, oxygen readings, which they then shared with all the other classes in Canada. And then they compared those with the International Space Station and communicated with an astronaut in space as part of the Canadian space program. So again, that cross-curriculum is really important. And we've also used microbits with UNICEF and the British Council in refugee camps in Greece, with Syrian and Libyan refugees coming into Europe. And again, what's brilliant about it is it allows people from different languages, from different backgrounds, to work together and collaborate using coding as an international language. Final point on what we've learned. Hardware on its own is not enough. The microbit is a brilliant tool, but if you give this to kids and teachers without anything else, it will fail. You need to ensure you have the software editors, you need to ensure you have the curriculum resources, and you need to ensure you have the capacity building for teachers. Also, accessories to enable people to take that journey and move forward. I was going to play a short film here, but I think I've run out of time, so we'll skip that, if I can. So I just wanted to finish off by saying that anyone can code, and we want to ensure that digital creativity is available for everybody so that everybody can take the first steps. We want to include those from underrepresented groups, including the royal family. And you see here Prince William taking his first steps on his coding journey. And anyone can code, well, almost anyone. This is Boris Johnson, who is our current Prime Minister, even if it's only for another couple of weeks. And again, we think that everybody can code. I just wanted to finish off by saying, what can you guys here in this room do to help us build a nation of inventors? At the moment, we've got something called the Do Your Bit Challenge, which launches in 2 weeks. This is done with ARM, World's Largest Lesson, and UNICEF. It's about creating good in the world with technology linked to the Sustainable Development Goals 2030. It's a competition where kids create solutions to problems that they're facing. And last year, we had a winner from Brazil who created a solution where rubbish was being thrown into her local lake, and she created an alarm system for when that happened so that she could go down there and either fish it out or tell the people off. And we flew her in from Brazil to London to take part in the final event. So that's open now, so please find out where your local workshops are happening. I know there's 2 or 3 happening here at this festival, and please take part. And also, just to spread the word around digital creativity, creative learning in Brazil. And we're always looking for volunteers to help us to translate resources and to get involved in feedback on how the microbit works. And that's it. I'd say, obrigado, thank you very much, and I hope you enjoy the rest of the Let's Go Crazy Festival. Thank you.